Hello there, this is Akash Murthy for the Audio Programmer. Today we're going to talk about all things related to preset managers. A preset manager can be as fancy as you want or as stripped down and minimal as you want. You can have panels popping in or sliding out. You can have categories of presets and a sorting system to filter through them. But in essence, if you take all the graphics aside, a preset manager performs a certain set of basic functions, like saving a preset, deleting a preset, and loading a preset, all of which we're going to try and break down today using this little simple app that we're going to build. We'll learn how to quickly hook up a few controls so that we can have a state ready to save and load. We'll learn how to create a few buttons and hook them up to a preset management system. We'll learn how to segregate a preset management system into its own service that we can reuse from time to time. And finally, we'll look at all the nuances and the bugs that can arise when we are trying to build a preset manager. If you find this content useful, do consider subscribing to the Audio Programmer. And if you're interested in digital audio fundamentals by any chance, do consider subscribing to my channel as well. The link's in the description. So without further ado, let's get started. So we're going to start off this project with a few of the items already built in. So I've got a few sliders here, a combo box and a toggle button. All of these could be controls for a delay plugin, for instance. But in this case, nothing is actually hooked up to anything. In the backend, there is no DSP. This is just a purely front-end application for the moment. The reason being that we are trying to build a preset manager, a state machine of sorts, to save and restore the state of the application. For this, we don't really need any DSP, so a few sliders and controls should do us fine. If you want to work along with me on this project, you can go to the repository that is linked in the description below. You can either clone or fork the repo there. And then you can switch over to the first commit, which is called initial commit, and you can start from there. So let's just look through what we've got in the initial commit. In the plugin processor, I've got an instance of the audio processor value tree state. This is going to store the state of the plugin. We're going to initialize the value tree state within the constructor. The name of the root element will be the project name itself. And I've got a utility method here, a static method called createParameterLayout. In createParameterLayout, which is within the utility namespace, we have defined the parameter layout with 5 different controls, 3 floating point audio parameters, a choice parameter, and a bool parameter. Back in the plugin processor, we've also filled up get state information and set state information methods appropriately as described within the JUCE tutorials. You can find one of these tutorials on the Audio Programmer page as well. There should be a link to one in the description. Within the plugin editor, the UI part of it, we're simply just displaying all the controls that are exposed by leveraging the generic audio processor editor class. In the constructor, we're going to pass the processor into this instance, and we're going to add make visible this generic audio processor editor, and we're going to set its bounds to be somewhere in the middle of our parent component. This is all we have so far, and this should, running the application in this current state, should give us what we just saw. A simple UI with a few controls exposed in the middle. Now let's start building the preset management system. The first thing we're going to try and do is put all the controls in place inside the UI. We're going to link those controls later, but at the moment, we'll just create a new class. I'll go over to ProJuicer, I'll create a new group, I'll call this GUI, and I'll add a new header file within it. This can be a header only file, or you can choose to split it up into a header and a source file as well. I'll call this preset panel. The preset panel will contain all of the controls required for a preset management system to function. So in here, I'll include the JUCE header. I'll create a new namespace called GUI, and I'll create a new class within it called preset panel. And I'll let it extend from the component class. Within it, I'm going to create a constructor for this class and a few member variables perhaps. So what do we need? So we need a few buttons. One to save the state of the plugin, so save button, a delete button, a previous preset button, and a next preset button. And to display all of the presets that are available for the application, we will use a combo box, and I'll call it preset list. And for good measure, I'm going to add the JUCE declare non-copyable with leak detector to mark the class as non-copyable and non-movable, and also to include a leak detector to warn us if this component is leaking memory. We don't have much choice over the non-copyability of it because a JUCE parent component is always non-copyable and non-movable. Right, so within the preset panel constructor, let's configure these buttons and set them up. So for the save button, I'll set the button text to be save. I'll change the mouse cursor of the button as well. I'll use the pointing hand cursor. This is just for aesthetics. I'm going to add and make visible this save button. And then I can handle the clicks of the button in two ways. One, I can assign a lambda for the onClick callback object. This is a lambda which takes in void and returns void. Or a more traditional approach would be to add a listener to this button so that when the button is pressed, the listener is notified. We're going to make the preset panel itself, which is the parent of the save button, as the listener. So we'll extend from button listener. Once we extend from button listener, we need to implement a pure virtual function defined within it, and it's called button clicked. And I'm going to move this into the private section. We're going to implement the button click method a little later on, but for now we'll move on. Whenever you add a listener, it's always good practice to remove the listener within the destructor. So let's do that right now. That's really all the configuration that's needed for this particular button, but we have 3 other buttons which kind of have similar needs. Let's create a really quick helper method to configure these buttons. I'm going to call this configure button. And as you can see, the only thing that really needs to change between all of the 4 buttons is the button text itself. So the configure button method will accept a reference to the button and a constant reference to the button text string. And I'm going to move the bulk of this code within the configure buttons method. And I'm just going to rename a few things here. So you may wonder why I added the const qualifier for the string reference, but omitted it for the button. Well, if I remove the const reference here and remove the reference itself, then this works, but there's string copying happening here. We want to try and pass things by reference whenever we can, but if I don't use a const reference here, I won't be able to use an R value reference here, meaning I won't be able to just pass the text save directly within the argument. I'd have to do something like create a new variable called button text and then pass that variable along, which seems a little redundant and quite frankly useless. So adding the const reference back here makes passing an R value reference work. We could have done const to the button as well, but we're literally mutating the state of the button, so we can't have the const qualifier there. Generally try to use const references wherever you can. Only when you're mutating the state of an object that you're passing it through, you have to remove the const. Right, let's just configure the rest of the buttons similarly. I'm going to make sure that I call the remove listener for all of these buttons as well. Right, that's all of the buttons set up. Now let's just set up the preset list combo box. So I'm going to set the text when nothing is selected, and I'm going to call this no preset selected. So when no preset is selected, that'll be the text that's displayed. I'm going to do the same thing with the mouse cursor here as well. I'm going to set it to pointing hand cursor. I'm going to add and make visible this preset list. We want to be notified when we twiddle down the drop down and select a new preset. I'm going to register the preset panel as a listener for this particular combo box as well. I'm going to add listener and I'm going to pass the this pointer. And of course, I'm going to inherit from the combo box listener class. I'm going to quickly make sure that we remove the listener within the destructor. And similar to the button listener, we'll have to override a pure virtual function, and this time it's called combo box changed. And we're going to implement this later as well, once we have something more concrete. And the last part that's actually needed to display all of these components is to essentially set their bounds. So I'm going to override the resize method. And in it, I'm going to declare a new variable called container. And this is going to be the container of the entire bounds of the parent. I'm going to reduce it by 4 pixels, just so that it doesn't stick to the boundary of the parent. It's going to be a const object. It's going to be our reference for proportions. We're going to use another object called bounds, which is going to be non-const, and we're going to try and slice portions out of that. So we'll set the bounds of save button, and we're going to remove a little bit of the bounds from the left edge. And we're going to remove about 20% of the proportion of the entire width of the parent. So I'm going to say container.proportion of width of 0.2. And then again, I'm going to try and reduce it slightly so that I have enough padding between the other components. So I'm going to repeat this for the previous preset button. And this is just going to be about 10% of the overall width. And in the middle will be the preset list, and this is going to be the biggest one, about 40%. The next preset button will be around 10% again. And finally, the delete button at the very end, that's going to be 20%, but we don't really need to slice out anything. We can just say whatever remains after doing all of that, that'll be our bounds. Now that we have exposed some controls within the preset panel, let's bring the preset panel into the parent. Let's create an instance of the preset panel within the parent, which is the editor. I'm going to include GUI/preset panel. I'm going to create a new instance called preset panel. Within the constructor, I'm going to add and make visible this component. And within the resize method, we're going to set its bounds. Perhaps about 10% from the top of the container would do us nice. Let's run the application and see what we've got so far. Alright, so this is quite good. So we've got a few buttons here. Obviously, clicking it doesn't do anything. We'll handle that later. But it seems like the resizing is not working exactly as it's supposed to. The height of the preset panel is increasing and decreasing as the width of the parent changes. So we've done something wrong here. So I'm just going to go back to the code, and you can see the bug right here. I've used proportion of width instead of proportion of height here. So we need 10% of the height, not 10% of the width. And I'm just going to change that and do a hot reload. This is a pretty new feature of Visual Studio 2022. So if you've got Visual Studio 2022 already in your system, you can do hot reloads on the fly, as you can see. Brilliant. So that's fixed the bug. I think we're in a good state to actually build the preset manager, the backend system that's going to handle the management of presets. All right. So I'm going to go into ProJuicer, and I'm going to create a new group here and call this service. And within this, I'm going to create a header and source pair. I'm going to call it preset manager. This is where the bulk of the preset management backend is going to lie. And this is the core of what this video is supposed to be. Within the header, I'm going to include the JUCE header. I'm going to create a new namespace called service. And within it will be our preset manager class. So we're going to define a few public methods here. I'm going to worry about the implementation a little later. But what would it need to have, right? So we would need a constructor, of course. We'll put that in there. What operations on presets do we expect to encounter? One, we might want to save a preset. So let's have a method for saving a preset. And it's going to accept the name of the preset. So it's going to be a const string reference called preset name. What else would we want to do? We'd want to delete a preset. So I'm going to create a new method for that. We'd want to load a preset. So load preset with the same preset name as the argument. Within this particular plugin, we'd want to do a load next preset and a load previous preset. For this, we don't really need any arguments because we will know the current state of the plugin, so we can switch it ourselves. What else do we need? We want to get all of the presets that are available so that we can display it within our combo box. Let's have a method called getAllPresets, and this will perhaps return a string array. We're going to put a const qualifier on this as well because this is just a getter function and it shouldn't modify objects within this class. We'll have another method to get the current preset. We'll have a couple of private member variables here. One perhaps to store the current preset itself. And then most of the operations that we do with presets will involve storing the state of the plugin, storing the value tree state. We need a reference to the audio processor value tree state object here, the one that's created within the audio processor class. And how are we going to get this reference? Through the constructor, of course. So we're going to add the audio processor value tree state as the only argument to our preset manager constructor. Well, I think this is pretty much all the methods that we need. Most of the functionality should be within one of these methods. So I'm going to go into the source file, just clear a few things here, and use the service namespace. I'll come back here and I'll generate implementations for all of the methods here. This is a resharper specific functionality. It's from JetBrains. It's quite nice, but it's a paid tool. I really find use for it, so I don't really mind paying for it. If you don't have this feature yourself, then you just need to manually create implementations for all these methods. Let's initialize the value tree state with the reference that gets passed through the constructor. Now in the constructor, what do we need to do, right? So firstly, we want to try and set up a default preset directory, a directory within our file system where all of the presets will be saved. So we want to consolidate and save all the presets within a particular directory within the file system. If the plugin runs for the very first time, this directory will likely not exist. So we would need to create it. But if the plugin runs subsequently, the directory would already exist. So we'd have to handle both of these conditions. And so we're gonna go back to the header and define where the default directory should be. So I'm gonna use a static const file object to define where the default directory should be. I'm also gonna define a variable for what the extension of these presets will be. And within the source file, we'll initialize what the default directory should be. So what do we choose for the default directory? Well, we have a few different options. I'm going to use the file class's getSpecialLocations method to find a few predefined special locations that we may want to save at. One of the directories that we may want to choose is Common Documents directory. As described in the docs, on a Windows file system, this may be stored within C, users, public, and documents. And on a Mac, it will be saved in users/shared. That seems like an appropriate directory to save presets in. But obviously, we can't just dump presets into this directory. We'll have to create subdirectories to differentiate the presets for this particular plugin from, let's say, some other plugin. So let's create a subdirectory for the company name itself of the plugin. I can just say tap here, but I'd rather prefer the company name within the project info class. And within the company directory, I'm gonna say get child file of the project name. So we would be storing all our presets within the common documents directory / the company name, which is tap, / the project name, which is JUCE preset manager. So obviously the directory that we are trying to get here doesn't exist. And that's quite fine, that's quite alright. The get child file method here doesn't actually try and fetch the directory within the file system. It tries to form a valid URI to locate the resource within the file system. It doesn't really need to exist yet. Besides that, I'm gonna initialize the value of extension. Let's just say it's gonna be called preset. If you save a new preset called, let's say my first preset, it'll just be saved as my first preset dot preset. All right, let's get on with it. So within the constructor, let's query if the default directory actually exists. If it doesn't exist, then we need to create the directory. So we're just going to call the create directory method for default directory. Now this returns a result object. So let's capture the result and see if it is actually successful. If the result failed, then we want to try and log the information out, saying that it did fail, and say and assert false here. So we can use the dbg macro to log things to the console. These logs will only be displayed when you're running a debug build. So I'm just going to assert false here so that we hit this breakpoint if something were to happen within our debug build. That's great. Now let's see how we can actually save a particular preset. The first thing we're going to do is some basic validation. If the preset name that's being passed to us is empty, then just return out of this function. We can't really do much if it's if the name of the preset is just empty. Next, what do we want to save here, right? So when we're trying to save the state of the plugin. So the state of the plugin is within the audio processor value tree state. Let's create a copy of this state. Let's say value tree state.copy state, and then I'll create an XML element from it. It's as simple as that. We've got all the functionality that we need within the JUCE framework. We just need to leverage it. Right, so the create XML method will actually return a unique pointer of an XML element to us. And what can we do with this XML element, right? We can say write to. We can actually write to a file or an output stream. But in our case, we'll just write to a file. So what's the file going to be? Right? So we've already know where the default directory should be. And we know what the name of the file should be without the extension. So I'm going to say default directory .get child file, and we're going to form the name of the file that we're going to save to. So it's going to be the preset name dot extension. And let's write to this file. The write to method returns a boolean. If it returns false, then wasn't able to write to this particular file. So we need to handle that case as well. If there's a problem when writing to it, we're going to put a debug message saying could not create this preset file, and we'll assert false here. That's pretty much it really to save the preset. Let's move to the delete preset method. Again, we're going to do the same validation here. We're going to check if the preset name is empty. If it is, then we'll just return out of this method. Next, we're going to try and check if the preset file itself exists in the file system. Well, if it doesn't, then we're just going to log a message saying the preset file doesn't exist and assert false here, and also return out of this method. If a file doesn't exist, then we don't want to move into the next steps after. If the preset file exists in the file system, then we're just going to say delete file on it. Again, delete file returns a boolean here so that we can query if the operation succeeded or not. If the delete file operation failed, then again we're going to just debug to the log saying that there's a problem deleting this particular file, and then we're going to assert false and return out of this. And the last thing we need to do is to set the current preset, or rather reset it to nothing. We're going to reinitialize it to an empty string. Which reminds me, I'll have to do the same within save preset as well. So we'll go back to save preset, and at the end, after saving everything, we're going to reinitialize the current preset with the preset name. Brilliant. Only a few more to go. For load preset, again, a similar validation at the start. We're going to check if the preset name is empty. If not, we'll return out of the method. We'll do the same validation that we did for deleting a preset. So we're going to see if the file exists on disk before we can actually try and load from it. If the preset file does not exist as a file, we'll just copy the same statements that we had used earlier. Now, let's just think about what we need to do here. We have a preset file, which is a sort of like an XML file within the file system. Now, we need to convert this file, or the contents of this file, into a value tree, and then replace the state of our plugin with this new value tree. Now, let's see how we can actually accomplish this. If you go to value tree, you can see that there's a static method called from_XML. This accepts an XML element. So we can actually create a new value tree from an XML element. How do we get an XML element to begin with? There's a class called XML document, which we can leverage. The XML document object accepts either a string or a file. A file is pretty useful for us in this case, so we'll pass the preset file into it. Now within from XML, the first argument, we're going to pass XML document.getDocument element, which will return the root of the document element for that XML. And this is pretty much what we need. Now this is going to return a unique pointer of an XML element, but from XML accepts an XML element reference. So we'll just dereference this unique pointer to get the underlying XML element. So let's capture the result of from XML, and we'll call this value tree to load. This is a value tree that we're going to try and replace within our application state, and thus it's called value tree to load. So we'll call the replace state method on value tree state, and we'll pass the value tree to load. And to finish it off, we will reinitialize current preset to be the new name of the preset. Great. Load preset and previous preset actually requires a full list of presets so that we can cycle through them. So let's do that first. So let's get all the presets as a list. I'll create a new string array object, call it presets. To fill up this array, we need to find all of the preset files within the default directory. So I'm going to query the findChildFiles method within the default directory. It asks me a few things. It asks me, what am I looking for? Are these directories that I'm looking for, or files, or both files and directories? I can go into file, types of files to find, and just find files, because we know that this is going to be a flat directory with only files within it. So all we're looking for are files. And then it's asking if we want to search recursively. The answer is no, we don't have any directories within, so we don't really need to search recursively. Then it's asking us for a wildcard. By default, the wildcard pattern is star, which just means that it'll match every file. This is basically a regular expression, sort of like a pattern matching directive. The wildcard over here, we don't want to match all files. We want to match only files which end with a .preset extension. So the wildcard will be star.preset. Now the find files method will give us an array of files. So let's collect that as file array. We can iterate through the entire file array and extract just the file names. So we'll have a range-based for here, const auto reference of file in the file array. We don't want the full file here, we just want the file name. So we'll just add the file name without the extension into the presets array. Once we've added all that, we'll just return the presets string array. The get current preset method is quite simple. We'll just return the current preset, the string object whose state we're maintaining. Now, only a couple more things to go here, loading the next and the previous presets. So to load the next preset, we want a few prerequisites, right? So we want a full list of presets. We want to know which index we are on, and then we can then select the next index. So let's get all the presets first. If all presets is empty, meaning if there are no presets that are saved within the file system, then we'll just return. We can't really load the next preset if there are no presets at all to begin with. Next, we'll find the current index within this array. So we'll say all presets index of the current preset, and that'll give us the current index. So since we're loading the next preset, what is the next index? Well, clearly it's just current index plus 1. But wait a minute. What if we're at the end of the array? Current index plus 1 will mean it'll move outside the bounds of the array, which will just fail and crash the application. So we need to handle that case. If current index plus 1 is greater than the size of all the presets, minus 1, we need the minus 1 here because, well, we're looking at indexes, not the total number. Anyway, if the current index plus 1 is greater than the size, we need to wrap it around so that it comes back to the start of the range. So if it is greater, then let's return the next index as 0. If not, it'll just be the current index plus 1. Now all we need to do is load the preset for the preset name within this index. So we already have a load preset method that we've defined. All we need to do is pass the name of the preset indicated by that index. So all presets get reference of next index. Brilliant. Now load previous preset. A lot of this will remain the same. For example, we still need to get all the presets. Then we need to say if the presets is empty or not, and then return if it is. And then we get the current index as well. All of this kind of remains the same. Once we have the current index, we want the previous index here because, well, we're loading the previous preset. What's the previous index? The current index minus 1. But again, if we are already at the very first index, which is the 0th index, then current index minus 1 will move it outside the bounds of the container. So we need to check if the current index minus 1 is less than 0, then we'll wrap it back around to the end of the range and return the previous index as the size of the array minus 1. Otherwise, if it's in any other arbitrary position, then we'll just decrement the current index by 1. Now that we've got the previous index, we'll just load the preset name that's at that index position. And that's really it. I think we've implemented all of the methods that are required for the backend preset management functionality to happen. Where do you think we should house the preset manager? Well, the preset manager can go within the plugin processor because there's only ever one instance of the plugin processor, and technically there should only ever be one instance of the preset manager itself. So we don't want the preset manager to be destroyed alongside with our editor whenever the editor window closes. So our best bet is to keep it within the plugin processor. So I'll include the service/preset manager, and I'll create a new instance of preset manager. Within the constructor, we will initialize preset manager with the value tree state. We have to make sure the value tree state is fully initialized before it can actually be sent to the preset manager. So the initialization order is quite important here. Then we'll have a very simple getter method to get the preset manager from within the processor. So we'll return the preset manager reference and we'll pass the preset manager out. Now, finally, to actually leverage the preset manager. So within the preset panel GUI class, let's say when one of the buttons is clicked. Let's imagine the button is the save button. So if button clicked is equal to the save button, we'll get the address of that. Then we want to save the preset. We want to be able to call something like preset manager.save preset. So clearly the preset panel component would need a reference of the preset manager. So let's create a new reference variable here called preset manager, and we'll accept a reference to the preset manager within our constructor as well, and just initialize the reference with the one that's being passed in. Now that we have a reference to the preset manager, we can actually go ahead and do something like preset manager.save preset. We still don't have the name of the preset, but we're getting there. Within the audio processor editor class, since we added a new argument to the constructor of preset panel, it says that no default constructor exists, which is true. So we have to initialize the preset panel within the constructor initializer list, and we need to pass the preset manager from within the audio processor. Brilliant. Now back to the preset panel. So let's say we click the save button. At a bare minimum, a file chooser dialog box would need to open. And we would then be presented with a dialog box where we can actually select where we want the preset to be saved and the name of the preset that would need to be saved. So we can utilize the file chooser dialog box window that's supplied within JUCE. File chooser accepts a few arguments. The first one is the title of the dialog box. Then after that, it's the initial file or directory that the dialog window should point to when it first loads. And then a constraint on the type of file or the file extension that's allowed to be saved. So for the dialog title, I'd say, please enter the name of the preset to save. The initial file or the directory that needs to be opened should be the default preset directory within the preset manager. So since it's a public static variable, we can reference that here. And the file pattern allowed again would be a regular expression. So it'd be star.extension. So any file with an extension of .preset. With the file chooser initialized, we can launch it asynchronously. To launch this asynchronously, we need to supply a certain flag to it, which is really not very intuitive. It should have ideally been a proper enumeration that it accepts, but never mind. So we need to pass what mode to open this file chooser in. Do we want to open it in a loading mode or saving mode? So within file browser component, I'm going to select save mode. And finally, we need to define what action needs to take place once we select a file. So we need to supply a lambda function which accepts a file chooser and which returns void. So over here within the lambda function, we then be able to decide what to do with the file that was chosen. Now there's an immediate problem here. So we've declared a file chooser here, and we're stating that the file chooser will be asynchronously launched. And then immediately we're losing scope of file chooser and it will be destroyed. So to make this work, the file chooser's lifetime has to be longer than the scope. So we'll move the file chooser out of this particular scope and maintain it as an instance variable. We'll make this a unique pointer as well, because we can defer initialization to a later point and we don't have to do it right away. Back here, we'll make unique a new unique pointer of type file chooser, and we'll initialize it with the same values that we'd given earlier. Now, since this is a pointer, we need to use the arrow operation to call the methods on it. And within the body of the Lambda callback, we will first get the file that was chosen by the user. We can get that by calling the getResult method on the FileChooser object. And we'll collect this as a result file. Then all we need to do is call presetManager.savePreset on that file. Now the problem here is that the preset manager is coming from outside, and we need to capture that by reference before it can be used within the Lambda. So we'll use a reference capture flag here for this Lambda so that preset manager can be used within the Lambda body. Next, let's handle a few other button clicks here. So if the button that was clicked is equal to previous preset button, then we'll just say preset manager.load previous preset. If the button that was clicked is equal to the next preset button, we'll just call the load next preset on the preset manager instance. And finally, if the button that was clicked was delete button, then we'll just call the delete preset method on that particular preset. What is the preset that we need to delete? Well, we can get the preset name by just calling getCurrentPreset. Now this is an unsafe function because you could accidentally click this button and then the preset will be lost forever. It is sort of wise to put some sort of dialog indication, like a prompt for the user, if they really do want to delete it or not, just for the sake of usability and user experience. But that's not really in the scope, and it's pretty simple to do that as well, so you can try it out on your own. We've handled all button clicks here, so we just need to handle the combo box being changed. If the combo box that was changed is equal to the preset list itself, then we call the load preset method on the preset manager class. And we need to pass the name of the preset that was clicked on. Now this is a bit convoluted to get. So we can get the name of the one that we have selected by using presetlist.getItemText, but that accepts an index. We can get the index by calling presetlist.getSelectedItemIndex. The preset list is still empty. We've not populated with any values yet. So the last thing we'd want to do here is to populate the preset list with some values. So we'll go over to the constructor and I'm going to call addItemList on preset list. Now conveniently, it accepts a string array, and we have a method which returns a string array, which is called getAllPresets on the preset manager instance. The second argument it accepts is the first item ID offset. We can say it starts from an ID of 1. Once we've added all the items, then we can set the selected item index. The selected item index may be different at different points of time, so we will get it from within the preset manager. It's not particularly straightforward to get the index from within the preset list itself, so let's break this up a little. We'll get all the presets first, and we'll call it all presets. And we'll get the current preset, and we'll just call this current preset. We can get the index of the current preset within the array of all presets by calling allpresets.indexOf on the current preset. And that will give us the index of the preset that should be selected. But by default, it's going to send a notification saying that the preset list has been changed. We don't want this notification to be going out because we've already registered for notifications to be listened to on the combo box. But those notifications should ideally be users manually selecting different items within the preset list. And it shouldn't be these sort of backend setups that trigger the listener to be activated. Alright, I think we've got a fair bit done here. Let's just go ahead and build this and see what we have. Well, the plugin's loading alright. If you click on the save button now, we're presented with a dialog window. And it says, please enter the name of the preset to save, as we coded it earlier. And then the path to the preset is C, users, public, documents, tap, and then within that there's JUCE preset manager. Currently there are no presets within it, as expected, but we can save one by choosing a file name. So I'm going to call this preset1 and just save it. Well, I'm not entirely sure if it's saved or not, because there was no visual feedback to give the indication that anything was saved. And twiddling down the combo box doesn't seem to showcase the plugin that was just saved. Let me just change the parameters again here and try saving another one. As you can see here, preset1 is already saved and is present here. And I'm going to call this next one max. And then again, there was no indication that anything was saved, and the preset combo box seemed to not indicate that anything is present. And for good measure, I'm going to save another one. I'll min all of these out, and then I'm going to save another preset, and I'm just going to call it min. Again, nothing there. But if I cycle through the presets using the left or the right arrows, you can see that it is actually changing the presets, though there's none listed in the combo box. If I close the plugin window and then reopen it again, then I can see that the combo box is fully populated with all the 3 presets that we just created. So what's happening here? What's going on? Well, it's quite simple really. If you go back to the code, if you go back to the preset panel class, we can see that we've populated the preset list only within the constructor. There are other moments in time, especially during saving a preset or deleting a preset, where we would actually need to reset or restore the state of the combo box. And that's what we're going to try and do now. Just make sure that all the behavior is as expected. Let's do a couple more tests here. If I twiddle down the combo box and select one manually within it, that seems to work perfectly fine. The behavior is as expected. And if I try to go ahead and delete one of them, let's say I'll delete the max one. Again, I don't really have an indication whether it was deleted or not. But if I click on save again, when it brings up the directory window, I can see that the max preset was in fact deleted and it isn't present there. So I think we have a fair idea about what's lacking and what needs to be fixed. So let's get cracking. The first thing I'm going to do is move all of this logic to load the preset list combo box outside so that I can reuse it. So I'm going to call this method load preset list. Since this method will no longer be called only from the constructor, we have to make sure that we clear the preset list before we go ahead and add more items into the list. If we don't clear anything, it'll just keep appending to the end of the list every time we save, delete, or whenever we call this method basically. We also want to make sure that we don't send any notification when we're clearing the preset list. We don't want the combo box changed method to be triggered when we're clearing the preset list. Right, let's see where we can actually use this method now. So within the button click callback, and if the save button was clicked, right after we call the save preset on the preset manager, we can choose to load the preset list again. And then similarly, when the delete button is clicked, after calling the delete preset method on the preset manager, we can choose to load the preset list all over again. But we have a couple more buttons here. The previous preset button and the next preset button. So for both of these buttons, we're cycling through the list of presets, but we have to inform the combo box that an element has been changed and it needs to reselect an element. We could technically do this by calling the method set selected item index on preset list, but as we found earlier, it's not very straightforward to find the selected item index based on the name of the preset that was selected. We would need all of the presets, so we would need to make another call to get all presets, and then also the current preset, and we need to find the index within it. Get all presets is not It's not always good practice to keep calling this method because it is an expensive method. It's a file system operation and it has to loop through all the files that are present within that directory. So we want to try and avoid a call to get all presets if we can get away with not calling it. So how do we deal with this situation here? If you think about the requirement here, all we need is the index. We were able to generate the previous and the next index within these methods. So why not just modify these methods so that they actually return the index position after they load the next or the previous preset? So let's just do that now. Let's change the return type of both of these methods to int. And in the next preset method, I'm going to return the next index. And in the edge case scenario, when all the presets is empty, then I'll return -1 instead of just returning nothing. -1 is a valid state here. When you're trying to set the selected index of a combo box as -1, it will set the state as not selected, which is kind of what we want. I'll do the same for load previous preset as well. I'll return -1 if all presets is empty, and in the end, return the previous index. Within the preset panel, I'm going to get the index position and pass the index into set selected item index. And for the notification here, for reasons that I've already explained before, I'm going to choose to not send a notification out. We can do pretty much the same thing for next preset button as well. Let's build the project and see what we get. Alright, so we've got the same situation as before. Let's try saving a preset. I'm going to max all of these sliders out and just save it as max. And you can see we immediately get a confirmation that the max preset was selected when the combo box selected max preset. And I can cycle the presets around as well, and you can see the combo box reacting accordingly. This is all good. So I'm going to quickly create a new preset. I'm just going to call it mid. And as you can see, the combo box reflected it correctly by adding the newly created preset as well to make it a total of 4. And if I click on the delete button, the combo box has been changed to nothing being selected, and the number of items within the combo box reflect the number of presets that are actually available. If I just close the plugin window and then reopen it again, you can see that the combo box state has been maintained perfectly, and the state of all of the sliders within the plugin is maintained as expected. This is cool, but there is a bit of a problem here. Let me create a new preset called mid. Now mid is selected, and I'm gonna close repo altogether. And let me reopen repo. Well, as soon as I do that, you can see that the combo box isn't selected anymore. The state of all of the controls within the plugin is correct. I can demonstrate that as well. So I can change, let's say one of the sliders to be slightly different. Save the project and then quit, and then reopen repo. You can see that the state of the sliders and the controls are quite consistent, but then it resets the state of the combo box. If I press the next preset button, the preset that's selected is max. We know that we had left the state at mid, and if it were to have been at mid, and if you had pressed the next preset button, it should have gone into min and not max. So clearly, though most of the functionality is working well, there's still some inconsistencies, especially when closing the project altogether and reopening it. But why is this happening though? And how do we fix it? So the first thing that I'm going to do is just go into the preset directory and open up one of the preset files. I'll open preset 1 and I'll open it with a text editor. This is pretty much how the state of the application is saved. Internally within the host, when the host requests the state of the application, and in the form of presets when we're writing it out to a file. It's saved in an XML format. And this XML file is quite simple. It's got a header at the start, and you've got the first root element, which is called JUCE preset manager. And then within it are 5 different parameters, one for each control. So the state of the application, when it's restored with this preset file, will restore the positions of the 5 controls perfectly well because they are listed here. But one thing that isn't listed here is which preset is currently selected. It kind of makes sense, right? If the preset file or the application state doesn't represent which preset is currently selected, then how will our application be restored to a state which has a preset name pre-selected? It can't, right? So that's one of the reasons why when we quit the application and restart the application, we were never saving the preset name anywhere to begin with. So it's lost. What we're going to try and do here is add a new property to this root to represent the preset name. Ideally, we'd want something like preset name equal to preset 1. And this is what we're going to try and implement. While we're here, I might want to include a version property as well, because it's generally good practice to implement versions within the presets that you're storing. So for example, let's say tomorrow in version 0.0.2, you have a new parameter with an ID of type 2, then you can differentiate which version of the plugin this particular preset came from. You can choose to be backwards compatible if you want to, and you can get a generally better user experience by making sure that the different versions of the preset are compatible with each other. Right, so where do we start? We'll start from within the plugin processor. In the constructor, after we've initialized the value tree state, we'll add a new property into its state. A property is nothing but a key value pair, and if you're setting the property right on the state, it'll add it to the root element, which is JUCE preset manager in our case. So I'm going to call the key as preset name. Since we're going to be using this property name elsewhere as well, let's just make it a static const so that we can avoid potential typo bugs. And the value, I'm going to set it to nothing because when the application starts off for the very first time, no preset is selected, right? And for the undo manager, I'll pass a null pointer. Similarly, I'm going to set a new property for the version tag, and I'm going to get the version number from within the project info class. With that being done, you can see a problem staring us in the face. The value tree state object is used within the preset manager, but we want to make sure that the value tree state is fully initialized before going into the preset manager, because the constructor of the preset manager might use the value tree state fully. But what's happening here is the value tree state is being passed into the preset manager, and then after that, within the body of the constructor, the value tree state's parameters are being changed. Its object state is being mutated. So to avoid this from happening, we want to defer the initialization of preset manager to a later point where we have completely initialized the value tree state. So I'm going to move this down to the bottom. But obviously, since this is an instance variable and it doesn't accept a default constructor, we will have to make this a unique pointer so that we can defer its initialization to a later point in time. We don't really have to change much else. For the get preset manager, we'll dereference this pointer and we'll get the actual preset manager. And while initializing it, I'll make unique a new preset manager, and that's it. Right, now we'll head over to the preset manager class itself. And within the constructor of the preset manager, we want to query the preset name property that might exist in the state. So we can query that property by calling value tree state dot get property as value, and then we can get the preset name property. Now we can assign this to current preset. Current preset is of course just a string object, and what you get out of get property as value is a value object. And a value object is quite a special object in JUCE. It's an object whose value can be bound to other value objects. And if one of them change, every other value objects which are linked to that one change as well. It's a pretty neat way of having just one property underneath the hood and having several value objects which refer to the same property. If one of them changes, the underlying property changes as well. So instead of maintaining current preset as a string, we can instead maintain it as a value object. Doing this, we can call a refer to method on the current preset. Here, one value object is referring to another value object. Those two will be inherently bound together now. Changing one will affect the other. So all we need to do to set the property within the state is just change the current preset. That will inadvertently change the state of the property named preset name. One caveat to keep in mind is that this binding connection, the reference between one value to another, breaks whenever you replace the value tree object with another one. Similar to how we are doing it over here during the load preset method, and even over here in the set state information method, where we're replacing the state of the value tree state. Whenever we do that, the connection between current preset and the property named preset name is broken. So that's a bummer. So whenever these sort of breaking changes happen, we need to re-establish the connection. We need to re-reference them together. We need to rebind the values together. So how do we do that? A simple way to do this would be to add a listener to the value tree state object itself, so that when we notice the state has been replaced, we can go ahead and re-establish the connection. So to make the preset panel itself a listener to the value tree, we will extend from value tree's listener class. There are plenty of methods that you can override from within the value tree listener class. There is value tree property changed. When a new property is added, that method is called back. And there is value tree child added and all sorts of methods here. But the one that we are interested in is value tree redirected. This method is called back when the state is replaced. So let's move that into the private section and implement this. As I said, all we need to do here within this method is to make sure that we re-establish connection between the current preset and the state's property called preset name. And voila, it's done. There are a few errors being thrown here just because we were previously using current preset as a string. Wherever there are errors, let's make sure that we're calling the current preset's toString method to convert the current preset from a value object to a string object. And instead of implicit conversions over here using the equal to sign, I'm going to explicitly call the set value method on the current preset object. And I'll do the same over here in delete preset. And again over here in save preset. In save preset, I'll just make sure that I move this above everything else. If we are setting the current preset value, we are also setting the property named preset name. So we want to set that property before we write to the file. That's really the reason why we need to move this above. All right, I think we've got everything here. Let's build the project and see what we get. All right, so it still says no preset selected, but that's fine. We'll select a preset now, save the repo project, and then quit repo. And let's just reopen it again. Excellent. Now the preset that we had previously selected is still showing up. And cycling through the next preset will give us the next preset in the list, which is min. Excellent. We've solved the problem that we previously had. We haven't written any of this out to a preset file yet. So if you want to check out how the preset file looks now with the new property added, let's just overwrite this preset that we have here. I'm going to go back in. I'm going to open up a preset named min. And you can see that the preset name is definitely present. It says min. But what happened to the version? We clearly added the version number as well in the state, but it's not here now. This is a bit of a tricky problem. The state of the application probably had the version number in it, but we were switching between different presets. And all of these presets are older presets, and they never had the version number within it. So as soon as we load one of the presets, we are loading the entire preset file as the state of the application. So we're essentially overwriting the state of the application with what exists within the preset file itself. And the version numbers never existed in any of these preset files. So let's do a little bit of cleanup so that we can actually get the version number in our application and within our presets. So I'm going to go ahead and delete all the presets that we had previously saved. Within the repo project itself, I'm going to get rid of the plugin and re-add it back. Now, as expected, there are no presets saved because we've deleted everything. Let's just quickly create a preset and see what we have in the state of the plugin. Now this is more like it. We've got the preset name as preset 1 and the version string as 0.0.1. I think this is a good dropping off point to end the discussion of preset managers. Of course, there are plenty more things that can be implemented, and I'm going to list a few suggestions that you can implement within your preset manager or your GUI. As I mentioned earlier, having a prompt displayed to the user before actually deleting the preset would be a pretty good idea. You can have a simple modal element that pops out, can prompt the user if they want to delete the preset or not, and based on the confirmation, the delete preset method will be called. In this tutorial, to keep things a bit simple, we went ahead and saved the preset name within the preset file itself. This is not particularly a good idea because if a user were to rename the preset file, they wouldn't bother going into the preset file and change the preset name property itself. There would be inconsistencies if the user were to rename the preset. So a better place to store this would be in the application properties. You can create a property file for your application which manages a collection of properties, and you can fetch and store the preset name from there. A link to the JUCE documentations for application properties class is in the description. And finally, if you really do want to support earlier versions of a preset, and if you want backwards compatibility with presets of an older version of the application, then the replace state method might not be the best choice for you. The replace state is a sort of nuclear option where it wipes the state and restores it from a loaded file or an XML. It's perfectly fine for this small example, but if you want to maintain backwards compatibility, if you want a little more control over the properties that are being restored and saved, consider looping through the list of properties that might be saved and only restoring those within our state if they exist or if they're relevant. Doing so, you can avoid unnecessary stale states or weird states that the application can go into, or at the worst case, avoid crashes. Well, that's it for this video. If there's good reception for the preset manager tutorial, then I might consider doing another video implementing all of the suggestions that I have mentioned here. But until then, take it easy.